Now let us concentrate on the disaccharides. So here when two monosaccharides are combined together by a glycosidic bond, a disaccharide is formed. So here the joining of simple sugars into double sugar happens by a condensation reaction which mainly involves the elimination of a water molecule from the functional groups only. So by this, one important point what you need to know is the disaccharides are water soluble in nature. And if you see, the most common disaccharides are maltose, lactose, sucrose, which have 12 carbon atoms which have a general formula of C12H22 and O11. And here the difference in these disaccharides are mainly due to atomic arrangements within the molecule. Now let us see the classification of disaccharides. The disaccharides are broadly classified under two groups: reducing disaccharide and non-reducing disaccharide. Reducing disaccharide is the disaccharide in which one monosaccharide, the reducing sugar, still has a free amiacetal unit. But in non-reducing disaccharide, in which the bond forms between two functional groups, which means none of the functional group from both the molecules are free to undergo reducing reaction. That is the reason these disaccharides are called as non-reducing in nature, because of unavailability of the functional group to undergo reduction reaction. So let us concentrate on one by one. The first one is the maltose. It is the disaccharide formed by the union of two alpha-D-glucose units. So by this, a glycosidic bond is formed between alpha 1 to 4 glycosidic linkage. So here the anomeric carbon, that is the first carbon atom of one glucose, is taking part in bond formation with the fourth carbon atom of another glucose, which means the hydroxyl group of fourth carbon atom of another glucose. This is how a glycosidic bond is formed between C1 and C4, and both are alpha D glucose units. That is the reason the nomenclature of this glycosidic bond is alpha 1 to 4 glycosidic linkage. So maltose may be alpha or beta depending upon the configuration at the free anomeric carbon atom. And maltose is reducing sugar. And it forms petal-shaped crystals during 𝐒𝐮𝐻 formation. And the next is, what are the sources for maltose? Maltose is mainly present in germinating cereals and also in barley. And commercial malt sugar contains maltose. And it may also formed during the hydrolysis of starch. The next one is isomaltose. So like maltose, isomaltose is also a reducing sugar. It contains two glucose units which are joined by alpha 1 to 6 glycosidic linkage, and in the maltose there is alpha 1 to 4 glycosidic linkage. And what are the sources for isomaltose? The partial hydrolysis of glycogen and starch produces isomaltose. So this is what you need to know about maltose and isomaltose. And next, let us move on to the another disaccharide, which is lactose. Lactose is a disaccharide mainly present in milk, and it is mainly formed by the union of galactose and glucose. So here the anomeric carbon, that is C1 carbon of beta galactose, is attached to the fourth hydroxyl group of glucose to form beta 1 to 4 glycosidic bond. That is the reason it is symbolized as beta 1 to 4. And lactose is also a reducing sugar. And here the lactose may be alpha or beta, same as I told you in maltose, mainly depending upon the configuration of first carbon of glucose molecule. So here lactose also forms osazones, which resembles a badminton ball or a hedgehog shape, or we can say that a pin cushion with pins, or also flower of touch-me-not plant. So this is how we will describe the osazones of lactose. And what are the sources of lactose? Lactose is mainly synthesized in the mammary glands in human beings as well as in all other animals. This is what is the chief source of production of lactose. And the next one is the sucrose. Sucrose is also called as cane sugar, and it is a disaccharide which is mainly made up of alpha D glucose and beta D fructose. So here the two monosaccharide units are held together by a glycosidic bond between alpha 1 and beta 2. So alpha 1 of glucose and beta 2 of fructose. We know that alpha 1 of the glucose contains aldehyde group, beta 2 of the fructose contains ketone group. So the bond is mainly formed between the aldehyde group of the carbohydrate and the ketone group of the fructose. So there is no free aldehyde or ketone group which is available to undergo reduction. That is the reason this sucrose is called as non-reducing disaccharide. So that is the reason sucrose will not form 𝐒𝐻-zone. So this is what you need to remember for sucrose. And what are the sources? It is mostly produced by sugarcane as well as sugar beets. So this is what you need to know about various types of disaccharides and its clinical importance.